So what we're going to be speaking about the next couple of days is dealing with factoring. And to kind of reiterate what factoring is factoring is pulling out parts of something, the parts of something. So like if I have the number 14, that can be broken down to 7 and 2. If I have 10, it can be broken down into 5 and 2, 10 and 1. Okay? And so we pull the things apart and break it down into the components that can make up whatever it is that we see. So when you look at numbers, when we say factor, you always think about what are the multiples of that number. Okay, it's like if you say what are the multiples of 20, you might have 10 and 2, 20 and 1, 5 and 4. Okay, those are multiples, those are factors of 20. We have the same concept when it comes to expressions. Okay, and you may think, why do I need to do this? The one thing that I know that factoring is used a lot on is definitely in the clothing industry. The point of factoring is pulling out the similarities of stuff. Okay, so what makes something similar? So if I pull out this one item and that one item, I can eventually find what something is similar to something, and then I can break it down to just where I have the differences. And definitely in the clothing industry, especially when it comes to patterns, is kind of knowing what that is. Then it allows you to actually determine more of like how much fabric you need, where would you cut things, and things like that. So you think about everything that we wear, like a lot of that is pulling out what makes something similar versus what makes something different. Okay, we're going to take what appears to be complex expressions, and we break them down, and we can simplify it, and then you realize that the equation ends up being where it's like X. Well, that's the one item that's different next to this, and you can make an evaluation how to actually like what you would do with that difference. Okay, I use the Denver Marathon thing all the time. How when they changed from going from a half marathon route to a marathon route, you guys remember that, right? And so instead of running around a circle twice, you're running up down now. And so by pulling out the factors, the things that are common between the two races, if you can pull those out, then they knew what they were dealing with, what was different, what they actually had to address, because all the other things were already identified. So if I can pull what's out similar, then I just have what's left over. Now I know what I'm dealing with. Okay, so that's kind of the point of identifying how you can do that. Okay, so for factoring, what we're looking at are how we are going to make the multiples of this. We have this big, huge equation. What are the commonalities? How can I break them apart? Okay, so we have a lot of different ways we can do that. We're going to start, we usually start from the most simple and work our way down to a little bit more difficult. Okay, so today we're going to start with the very first one. The greatest common factor is the number one thing you always want to look to before you even do anything else. And the greatest common factor, when you see that, is what is the greatest value or number or variable that is in common to all elements that you see. Okay? So if I have the number 10 and I have the number 12, you would say, what's the greatest number that goes into both of those? What would the greatest number be of 10 and 12? 2, right? But if I have 10 and I have 20, what would be the greatest common factor of both of them? 10, right? Because 10 is the highest number that goes into both, right? And then you pull that out, and then what you're left over is the other part of it, right? So we're going to look at how to pull the greatest common factor out of everything. So you have to look at each element and say what number and terms or variables is the same in everything that I could pull out, okay? So if I look at, let's say the first one here, the 4g squared minus the 2g. So always look to the number first and say what's the highest number that goes into every element, if at all, okay? And then you look at that, and then you want to pull it out. So is there any number that goes into 4 and 2? 2. So I'm just going to write whatever the greatest common factor, whatever number or variable I'm answering to, I pull it off to the left. All right. So is there anything related to g's that are the same? Yeah, I have 2 g's here because g squared is g times g, and I have 1 g there, so they both have a g in common, correct? So I could just take a g and put it on the outside. And then in your brackets, in your parentheses, is what is left over. So basically at the end, if I would do the distributive property, I should get my answer again, right? So if I take a 2g out of 4g squared, what would the term have to be inside to make it a 4g squared again? 2g. Right, 2g, right? Because I have g times g, that would give me g squared. Then I keep my minus sign, so each term you want to look at separately. but you can't put it out of the parentheses unless it is an answer to each term inside, okay? So what would I have left over here if I pulled out a 2g? I have a -1, yeah, or 1, because that negative is there. So if I take the 2g and multiply by 2g, I would get 4g squared, correct? If I take 2g and I multiply by -1, I would get -2g, right? Okay. So when you look at each item, you ask yourself, what is something that it has in common, what is the highest thing it has in common for each term, and then pull it out to the left, and then the inside is going to be what is left over. Okay? Alright, so looking at number 2. So look at the numbers. What is the highest number you could pull out of each one of those, if at all? 3? Okay, so if I pull out a 3, okay, and then how about variables? Are there any variables I could pull out? X. So you're going to look for the lowest exponent. That's going to be your greatest common factor for that term, assuming it's in each term, right? So that's what you look for. So the x is the lowest, x1 is the lowest, so that's the highest I could pull out, right? So then I'll pull out a 3x. Then I'm left with my parentheses. So if I pull a 3x out of 12x, what am I left with? I'm just left with 4, because a 4 times 3x would give me 12x. Then I have a minus. What would I need to multiply 9x cubed by, or 3x to get 9x cubed? -3x squared, right? Because again, I'm pulling 1 out, so therefore 1 goes away, and that makes it squared. And then what would I be left with the 15? Plus 5, and then I need to make it an x squared, so I need another x. Okay? At that point, just reevaluate there's not anything that you missed. Like, is there something that's common? Like, if I saw another x in there, I'm like, oh, I probably could pull another x out. Then you want to make sure that you have reached the highest one. Okay? So greatest common factor for every single thing you do, you want to ask that first. Get the greatest common numbers out, because then you're working with smaller numbers in the end, and that's a lot easier. You're working with smaller variables, exponents, you're working with smaller numbers, it just makes it easier. So you always want to look to that first. Does that make sense? Alright, so then when you're done with that, there's like a bunch of different ones we're going to go through. The next one is recognizing what we call the difference of the squares. So if you notice I have x squared minus 1 here, if I look at that, I'd be like, I don't think anything seems common, does it? Like, I'd go greatest common factor, right? Does anything look like there's a greatest common factor in there? No. I mean, they both have 1s. You don't really pull a 1 out, right? They don't both have x's, so I can't pull x out, right? But whenever you have a variable minus another number, okay, so here I have a variable, right, and I'm minusing a number, I need to ask myself, could it be this difference of squares? That's what the 2 squares equals, the difference of squares, okay? And what the difference of squares is, looking to see if a variable and the constant are perfect squares, okay? So the number one thing you want to look at, if it's a variable with a number, minusing a number, it has to be minusing a number, okay? Is this number a perfect square? So, well, x squared, x times x, right? Do you guys remember what a perfect square is? Something times itself, right? Well, is x times x, that's really x times x, right? Is that a perfect square? Yeah. How about 1 times 1? Is that a perfect square? Yeah, 1 times 1. So when I have it where the answer is yes, then I can use this formula right here, okay, in which I can just rewrite this, where the factors are going to be in parentheses, the variable without the x, squared, so x squared is just x, right? 1's a minus, 1's a positive, and then it's going to be the square root of the perfect square. So the square root of 1 is just 1, right? Okay. Now this one isn't as easy, I don't think, to see it as a perfect square, because you don't usually look at 1 and say it's a perfect square. Like 4 we might see, 25 we might see, 49 we might see, but 1's kind of an odd one, right? Because you don't think of 1 times 1, but it is. So when you see that. Okay, so when you see something that is a variable minus a number, ask yourself, could this fall underneath the difference of the squares? And then what you want to do is that a perfect square? Is that a perfect square? If the answer is yes, then you can just rewrite it by taking the square root of the first one, have a minus and a positive, and then the square root of the second one. Because what happens is when you do the distributive property, the middle terms actually cancel themselves out. You see that? So if I remultiply this out, x times x is x squared, x times 1 is plus x, negative 1 times x is negative x, and then negative 1 times 1 is negative 1, right? So when I combine these, this and this cancel, don't they? They become 0. So therefore, what am I left with? I'm left with x squared minus 1. Is that my answer? It is. Okay? So let's see how this works with another one. So let's look at number 2. Okay? Here I have a variable, okay, minus a number. So I'm going to ask myself, is this a perfect square? Well, is 4 a perfect square? Yeah, what's the square root of 4? 2. What's the square root of m squared? M. So that's a perfect square, right? Alright, is 9 a perfect square? It is. 3 times 3, right? Okay, so this falls underneath this where it is this situation. So I'm going to rewrite this. Alright, what's the square root of 4? 2. What's the square root of m squared? M. Okay, 1 becomes a minus, 1 becomes a positive, and then the square root of 9 you said was 3, right? So 3 and 3. Okay? So does everyone see? Then that is the factor. These are factors of this equation right there. Meaning this is these are multiples to make that answer. Okay? Good so far? Yes.
Does it matter in which
Positive or negative? Nope. No, you could do a positive and a plus and a minus there. That's fine. Yeah. It's just as long as one is positive and one is negative, that's fine. Did y'all hear what that question was? Does it matter if this is positive and that's negative? It doesn't. Okay? Alright, so let's try number 3. See if this falls underneath that rule. Number 3. Is 4x squared a perfect square? Okay. Is 400 a perfect square? Well, what are some factors of 40? We have 40 times 10. What else do we have? 20 times 20. Is that a perfect square? Yeah. Sure is. Alright, so can I rewrite that then? Alright, so what goes first? What would this be? 2x. Okay, plus or minus, doesn't matter which way you do it. And then what would then be in the 20? Okay. Alright. Now, if you didn't see this, okay, there's another thing that you could have done first. Asking yourself the greatest common factor, right? We didn't do that on this one. Is there a greatest common factor in number 3? What is the greatest common factor in number 3? It is 4. So if I pull out the greatest common factor, I would do 4. I would be left with then x squared minus 100. You might see that a little bit easier, right? Maybe, maybe not. Is 100 a perfect square? Is x squared a perfect square? Yes, so I could then even go farther with this, and I would do 4, and then I would have x minus 10 and x plus 10. That would be the same answer as above. Okay? Does that make sense how I did that? Okay, so look at number 4. Right now, if I would say, is that a perfect square, your answer would probably be no. Okay, so the number one thing we should check is what? This is number 1. Right, so this is number 1. Always check greatest common factor first. So let's check number 4. Is there a greatest common factor I can pull out? Is there anything I could pull out of 2y to the 5th minus 50y? 2? Okay, let's pull out a 2. Is there anything else I can pull out? Is there anything else they have in common? A y? Yeah, pull out a y. So now what am I left with? Y to the 4th minus what? 25. Alright, so now I have a variable minus a number. If I have a variable minus a number, what do I want to ask myself? Are they perfect square? Is y to the 4th a perfect square?
Yes.
Yeah, y squared times y squared would give me So basically you look at the exponent, and if the exponent is a number that's a perfect square, then the answer is yes to your variable, right? Does that make sense? So this actually can then get broken down into y squared and y squared. What about 25? Is that a perfect square? It is. 5, right? So minus 5 plus 5, and then I bring down the 2y, so my answer would be 2y, and then you would have the two factors of y squared minus 5 and y squared plus 5. Questions on that? Good? Okay, move on? Alright, so now we get down to factoring trinomials. Trinomials means 3, right? 3. With a leading coefficient of 1. So leading coefficient means you're in standard form, right? And there's nothing in front of your squared. Right? Good? Okay. So you guys are probably used to seeing this, where you do the little X. Familiar with that one? No? Yes? Okay. Basically what you want to do is as follows. You need to find a number that this is the multiplication, so when you multiply you're going to get negative 10, but when you add you get 3. Okay? So the rule on factoring these is where you multiply to get the, I'm going to write this real quick. I don't know if you guys remember seeing this or not. You guys remember seeing this? ax squared plus bx minus c. Okay? So you need to find a number, the set of numbers that when you multiply a times c, so this is going to be the a times c, you're going to get, when you add it together, you're going to get b. So when a plus c, you're going to get b. Okay? So an example would be I have negative 10, so if I do the x, I have negative 10 here, and when I add it together, I'm going to get 3. So what are factors of negative 10? We have negative 10, 1. We have negative 5, 2. We have 5, negative 2. We have 10, negative 1. Right? So those are all possible factors to get that number, right? So when I multiply them together, I'm going to get negative 10. However, when I add them, I need to get a positive 3. Right? So do negative 10 and 1 get me a positive 3? No. Do negative 5 and 2 give me a positive 3? No. Do 5 and negative 2 give me a positive 3? Yes. So therefore 5 and negative 2 are the two numbers that when multiplied together I'll get negative 10, and when I add them I'm going to get 3. Does that make sense? So this is the add and this is the multiply. So therefore this tells me what my factors are going to be, right? So now I know that I have an x squared, so I'm going to have, I'll take the square root of whatever that value is, so that becomes x, and then these numbers then become my answers on the side. If it's a positive 5, it becomes plus 5. If it's a negative 2, it becomes a negative 2. You follow the signs that you have there, okay, or you follow the signs that you have here, whichever way you like to do it. Okay? And then those are the factors. These are the multiples that will get you that. So if I would actually distribute that out, I should get that answer. That'd be x squared, that'd be a minus 2x, that'd be a plus 5x, and that'd be a negative 10. And so when you add that together, that would be the case. Okay? So when you're doing the factoring of trinomials with a leading coefficient of 1, then you can find the numbers that when multiplied together you get this value, you get your c, and then when you add it you get your b. Does that make sense? Okay? So see if you guys can't try number 2 on your own. See if you can't try number 2 on your own. Alright, so when you have a positive and you have a negative, you know one of your numbers has to be negative, right? Okay, so at this point, I am going to say I have 14 and negative 1. I have negative 1, 14. I have 7 and negative 2. I have negative 7 and 2. Okay, any other factors I haven't figured out? Okay, so then 14, negative 1, does that give me negative 9? No. Negative 1 and 14, does it give me negative 9? 7 and negative 2, does that give me negative 9? Negative 7, 2, does it give me negative 9? All right, so what am I missing?
The negative
-7, -2. Very good. Very good. Because I can add them to get a negative. When I multiply, it becomes positive, right? So then I have -7, I have -2. Okay? So now I take the square root of that. So what's the square root of m to the 4th? So square root of m to the 4th is m squared. Okay? I have a -7, and then I have a -2. Does everyone see then how those became my middle terms? Okay. Alright, so I'm going to have you try 3 and 4 on your own. Before you try 3 and 4 on your own, though, if you notice the coefficient is not 1, correct? So, again, the number one thing, what do I need to ask myself? Greatest common factor. So whenever you don't have a coefficient of 1, that should just be a little signal in your brain saying, let's try the greatest common factor first. Okay? See if there's any coefficients I can pull out. See if there's any variables I can pull out. Okay? Make it more simple. Okay? So try the number 1, the greatest common factor first, and then try to then factor. Okay, I'm going to give you guys a minute to do that. Alright, so when you have a trinomial, and the coefficient is not 1, well, first of all, you just want to check anyway if there's anything you could pull out. Greatest common factor, okay? Ideally, what you're trying to get is where you have a squared, exponent of 1, and then a constant. That's a nice little trinomial you can try and factor, okay? If you have anything else, where you have x's in all of them, you don't have a coefficient of 1, that needs to be your trigger that I need to look to see if there's a greatest common factor I can pull out. Okay, everyone hear that? Because I guarantee it's going to be something that you'll get stumped on. If you don't see it in standard form, where it's ax squared plus bx minus c, that's a signal that there's a greatest common factor to pull out. Okay? If coefficient is not 1, that's a signal that there's probably a greatest common factor to pull out. Not always, but that's your signal. Okay? So my signal is, oh, I don't have a coefficient of 1, so I'm going to see if there's anything I can pull out. So I can pull out a 2. I'll pull out a 2. I rewrite it. Okay? Make sure you pull out a 2 out of each term. So if I would multiply it straight through, it would be the same thing. So you haven't changed the value of it yet, right? At this point, I'm going to factor this. So I'm going to do -20 and -8. So -10 and 2 will give me both of those. So then I will rewrite this middle term, so the 2, I'll rewrite this as x minus 10 and x plus 2. Okay, is everyone good on how I go from there to there? Okay. Alright, so let's look at number 4. Now number 4 is different. Again, my trigger is, it's not in ax squared plus bx minus c, is it? Or plus c, is it? It's y's and everything. So my trigger is, hey, is there a greatest common factor? Is there anything I can pull out of each one of those? I could pull out a 3. Is there anything else I can pull out? I can pull out a y. Okay? When I do that, let's see how I simplified this. So, if I pull out a 3y out of 3y cubed, what am I left with? Just y squared. Okay, what am I left with out of a 33y squared? Plus 11 what? Y. Because there's 2 of them there, I'm pulling 1 out, I should have 1 left over. And then when I pull a 3y out of 90y, what am I left with? I'm left with 30. Okay, does that look a little bit more pleasing in regards to factoring? It sure does, right? Because now I'm at the ax squared plus bx plus c, right? That's your goal, to get it down to that. Now I can factor this middle part. The key also is make sure you don't lose your 3y. That has to go down. So I'm going to take this part, and that's when I'll break it down. I'll have 30 here, and I'll have 11 here. Okay? So now I need factors of when I multiply equal 30, but when I add them equals 11. 5 and 6. Nice job. So now those become my middle terms. So I bring the 3y down, don't lose that, and then I rewrite this x plus 5 and x plus 6. It's what? Oh, y. Y. Sorry. Yeah, you're right. Y. You changed no variables on me. Come on. Okay. All good? Alright. So questions on leading coefficient 1. Alright, we're going to flip. We'll work with this flowchart next time. Don't worry about it. Okay. Alright, so now we're going to factor 4 terms by grouping, okay? I actually like this one. I think this one's fun. I think it's easier, but that's just me. Okay, I have 4 now, so it's not a trinomial, and now I have 4, okay? And so what we do is we put it in standard form, so highest to lowest, okay? And we're going to do what's called grouping. So basically you take it and divide it in half. Okay? Right? Divide it in half. So I'm going to work with the left side, I'm going to work with the right side. Okay? So I'm going to look at each one separately, and number 1, I'm going to say greatest common factor, right? So looking at this one, is there a greatest common factor on x cubed plus x squared? X, right? So I'll pull that out and I rewrite this as x squared plus 2x. Oh, looks like I can pull something else out then, doesn't it? Yeah, so I can actually pull out 2 x's. Leah, question?
Yeah, so what about the other?
We're going to go back to that.
Did you say that already?
It's okay.
Sorry.
It's okay. So notice how I had another x, so I know, hey, I actually can pull more out. Look to the high, or look to the lowest exponent. That would be the most you can pull out, right? So how many x's can I actually pull out of there? 2. So I'm going to make that x squared. And then I'm going to be left with x plus 2, right? Okay. Now, I have this plus 3x plus 6. Is there anything common between the plus 3x plus 6? There's a 3, right? So I'm going to do plus 3. What am I left with? X plus 2. Okay. So, if you notice, I have an x squared times an x plus 2. I have a plus 3 and I have an x plus 2. If this was written as, let's say, 3a plus 2a, what do I have in common here? An a, and I could actually pull that a out, right? I could rewrite this as a and then 3 plus 2, right? Well, this is the same situation. So I actually can combine the x plus 2's together, and then I can combine what I have as coefficients, right? Just like I did there. So I'm going to do that. I'm going to take my x squared plus 3 and make that one factor, and then I have a combination of the x plus 2's. That's like my a, so I just write it as x plus 2. Nope, you don't have to write one of them, because it's just like a. See, if I have 3a plus 2a, I just need to pull the a out, and then it's 3 plus 2, right? Well, this is like my x squared, that's like my 3, and that's like my x plus 2. Okay? So grouping, I mean, when you have 4 terms, I actually like it. I think it's really easy. The key is, when you get to the second part, is you're trying to get this part to equal what this other side was. So that's kind of a key as to what I need to pull out to make it equal that. So it almost gives you that little hint, right? So if I wasn't sure what was common, I'd be like, well, I need an x plus 2. How can I make that x plus 2? Oh, I pull out a 3. Okay? All right, so let's look at number 2. All right, draw a line down the middle. You have your 2 parts. So on this one here, we want to say what the greatest common factors, or anything common in any of these. And 9m squared, right? When I do a 9m squared, what am I left with? M plus 2, right? Alright, so now, notice how this side right here, I kind of think I need it to be m plus 2 in the parentheses, don't I? Right, that's my hint. What would I need to pull out of this so that m plus 2 is left over? A negative 2. Oh, no, maybe something more than that. Negative 4. If I pull out a negative 4, what am I left with? M plus 2. Right, so you kind of use this one right here as your hint to what needs to get pulled out to make that the same. Because your goal is to make this and this the same. That's what your goal is. Right? And now I can rewrite this. I can rewrite this as 9m squared minus 4, and then in parentheses I would write m plus 2. Okay, I'm going to ask you a question. Could I break this down any farther? Probably is a good answer. Probably. It's something we talked about earlier. If I have a variable minus a number, I ask myself, is it a perfect square? Is 9 a perfect square? Is m squared a perfect square? Is 4 a perfect square? Yeah, so how could I actually rewrite this?
Teachers, please excuse this interruption. A couple quick announcements and then the trivia winner. Today's the last day for those to check lost and found. It's going to be bagged and given away to charity, so if you're missing something, check there. So our trivia question was the two states with the highest graduation rate percentage-wise, and if you remember, California ranked 34th, so you're winning. Number 2 state would be North Dakota, and the number 1 state with the highest graduation is Iowa. Everybody have a great weekend, and go support the different teams. Good luck cross-country tomorrow, boys and girls teams. Good luck football team and volleyball or anyone else playing. So have a great weekend and be safe.
All right, you guys all good with